Finding percentage composition of an element. Hello and welcome back to our channel Target Teach Tutors. In today's lesson, we are unpacking some key chemistry concepts that will simply those tricky chemical calculations. This video includes the percentage composition of elements in a compound or a molecule. To grasp this topic, it's important to build on what we covered in the last lesson, calculating relative atomic mass and relative formula mass. There's a link in the description to view this topic. By the end of this video, you will have a clear understanding of how to find the percentage composition of elements in compounds and molecules. This is how much percentage of each element is present in a compound. This concept becomes much clearer when we walk through a few examples, so let's break it down step by step. Example 1. Hydrogen chloride, HCl. Find the percentage composition of hydrogen and chlorine. Relative atomic mass for hydrogen is 1 and for chlorine 35.5. First of all, we have to find out the relative formula mass for hydrogen chloride. To calculate this, in hydrogen chloride, hydrogen atom is 1, so atomic mass is 1 times 1 is equal to 1. Chlorine atom is 1, so atomic mass is 1 times 35.5 is equal to 35.5. So relative formula mass for hydrogen chloride is 1 plus 35.5 is equal to 36.5. The formula for calculation of percentage composition of hydrogen and chlorine. First of all, we are going to calculate for hydrogen. Percentage composition of hydrogen is equal to total relative atomic mass of element, that is hydrogen, divided by relative formula mass of compound hydrogen chloride multiplied by 100. It is equal to 1 divided by 36.5 times 100 is equal to 2.7. Therefore, the percentage composition of hydrogen in hydrogen chloride is 2.7. Now we are going to find the percentage composition of chlorine. It can simply be calculated by 100% take away percentage composition of hydrogen. That means 100 minus 2.7 is equal to 97.3%. Or it can be calculated using the formula. Percentage composition of chlorine is equal to total relative atomic mass of element chlorine divided by relative formula mass of the compound hydrogen chloride multiplied by 100. It will give the same answer, 97.3%. Example 2. Find percentage composition of sodium, hydrogen, carbon and oxygen in sodium hydrogen carbonate. Relative atomic mass for sodium is 23, hydrogen is 1, carbon is 12 and oxygen is 16. In sodium hydrogen carbonate, sodium atom is 1, so atomic mass is 1 times 23 is equal to 23. Hydrogen atom is 1, so atomic mass is 1 times 1 is equal to 1. Carbon atom is 1, so atomic mass is 1 times 12 is 12. Oxygen atoms are 3, so atomic mass is 3 times 16 is equal to 48. Relative formula mass for sodium hydrogen carbonate is 23 plus 1 plus 12 plus 48 is equal to 84. Now we start calculating the percentage composition of each element in sodium hydrogen carbonate compound. Percentage composition of sodium is equal to total relative atomic mass of sodium divided by relative formula mass of sodium hydrogen carbonate multiplied by 100. It means 23 divided by 84 times 100 is equal to 27.4%. Therefore, percentage composition of sodium in sodium hydrogen carbonate is 27.4. Now we are going to calculate percentage composition of hydrogen. Percentage composition of hydrogen is equal to 1 divided by 84 times 100 equals to 1.19% or 1.2%. Therefore, percentage composition of hydrogen in sodium hydrogen carbonate is 1.2. Now we are going to calculate percentage composition of carbon. Percentage composition of carbon is equal to 12 divided by 84 multiplied by 100 is equal to 14.3%. Percentage composition of carbon in sodium hydrogen carbonate is 14.3. Now we are going to calculate percentage composition of oxygen. Percentage composition of oxygen is equal to 48 divided by 84 times 100 is equal to 57%. Therefore, percentage composition of oxygen in sodium hydrogen carbonate is 57. The percentage composition of oxygen in sodium hydrogen carbonate can also be calculated by adding percentage composition of sodium hydrogen carbon take away from 100. That means 100 minus 27.4 plus 1.2 plus 14.3 is equal to 57.1. To round up, it will be 57%. Example 3. Find the percentage composition of carbon in magnesium carbonate compound. The chemical formula for magnesium carbonate is MgCO3 twice. Now we try to calculate the number of elements in the compound. It is only for the practice purposes, not in the working out for this question. The number of magnesium is 1, carbon is 2, oxygen is 6. Relative atomic mass of elements will be given. Magnesium is 24, carbon is 12, oxygen is 16. Now we have to calculate MR for magnesium carbonate is. Before calculating the relative formula mass of magnesium carbonate, first of all we have to calculate the total masses of magnesium, carbon and oxygen elements. This calculation is also done for the practice purposes. Magnesium atom is 1, so atomic mass of magnesium is 1 times 24 is 24. Carbon atom is 1 times 2 is equal to 2, so total atomic mass of carbon is 2 times 12 is equal to 24. Oxygen atom is 3 times 2 is equal to 6, so total atomic mass of oxygen is 6 times 16 is 96. Therefore, relative formula mass of magnesium carbonate is 24 plus 24 plus 96 equal to 144. Now we are going to calculate the percentage composition of carbon. The composition of carbon mass in the compound is 24. So percentage composition of carbon is equal to total relative atomic mass of carbon divided by relative formula mass of magnesium carbonate multiplied by 100. Is equal to 24 divided by 144 times 100 is equal to 16.7%. Likewise, you can learn how to find the percentage composition of magnesium, oxygen in this compound. Example 4. Find the percentage composition of hydrogen in ammonium gas molecule. Relative atomic mass for nitrogen is 14, hydrogen is 1. Before we calculate relative formula mass for NH3, we have to find the number of atoms and mass of nitrogen and hydrogen in NH3 molecule. Nitrogen atom in NH3 is 1 times 1 is equal to 1 and its mass is 1 times 14 is equal to 14. Hydrogen atoms in NH3 is 1 times 3 is 3 and its mass is 3 times 1 is 3. So relative formula mass of NH3 is 14 plus 3 is equal to 17. Now we are going to calculate percentage composition of hydrogen in NH3. Is equal to total relative atomic mass of hydrogen divided by relative formula mass of ammonia NH3 multiplied by 100 is equal to 3 divided by 17 times 100 is equal to 17.6% or 18%. We are able to calculate percentage composition of nitrogen in NH3 molecule. Here are some homework question examples focused on calculating the percentage composition of elements in various compounds. We offer homework questions in each lesson that have numerous advantages to boost learning and retention. How does homework help students? Read this by clicking the link which is given in the description. These are the questions for the students to work out. Question 1. Calculate the percentage composition of hydrogen and oxygen in a molecule of water, H2O. Relative atomic mass of hydrogen is 1, oxygen is 16. Question 2. Percentage composition of sodium, carbon and oxygen in sodium carbonate. Relative atomic mass of sodium is 23, carbon is 12, oxygen is 16. Question 3. Determine the percentage composition of magnesium and oxygen in magnesium oxide, MgO. Relative atomic mass for magnesium is 24, oxygen is 16. Question 4. Find the percentage composition of sodium, hydrogen, carbon and oxygen in sodium hydrogen carbonate. Relative atomic mass of sodium is 23, hydrogen is 1, carbon is 12, oxygen is 16. Question 5. Find the percentage composition of calcium, carbon and oxygen in calcium carbonate. Relative atomic mass for calcium is 40, carbon is 12, oxygen is 16. Question 6. Calculate the percentage composition of carbon, hydrogen and oxygen in glucose C6H12O6. Relative atomic mass for carbon is 12, hydrogen is 1, oxygen is 16. Question 7. Calculate the percentage composition of calcium, phosphorus and oxygen in calcium phosphate Ca3PO4 twice. Relative atomic mass for calcium is 40, phosphorus 31, oxygen is 16. That wraps up today's lesson. I hope breaking down these examples helped make percentage composition calculation a lot clearer. If you found this video helpful, don't forget to give it a thumbs up and subscribe to Target Teach Tutors for more step-by-step guides on chemistry and other components in science. And if you still have questions or want to see more examples, drop a comment below. We are here to help. Thanks for watching and we'll see you in the next video.